I'm Daniel, and Alina is our Chief Spring Officer.
Yes, and we are here to talk with you about migrating your applications to Spring and GraalVM, how exactly you can do it, things that you need to know, and why you would do it in the first place. So if you want to catch up with us, if you have any questions, or if you want to ask us for demos, just follow up. You can find us on all kinds of social media. We are on Twitter, and also Danielle is inviting me to move more to Blue Sky, so you can also join us in our journey to explore Blue Sky, and you can ask us questions there as well. So let's go. And as you can see from the title, this is a session about how you can build applications with Spring and GraalVM. It's much easier now since the release of Spring Boot 3.0, when Spring introduced the out-of-the-box support for native image and native image compilation. You could have built applications with Spring and GraalVM before 3.0, but now it's even easier because the support is now built in, and you can choose native image as one of your Spring dependencies when you start your project. So with that being said, let's look at an application that just works, TM. And join me in my little pray to demo gods and internet gods to make sure that I can connect to my cloud instance. But let's see if we can get our application to run. So here I have my machine, and we have, as you can tell from the name of the directory, an AI.
Can you zoom in a little bit?
Yeah, 1 sec, sorry. Yeah, so you can tell that we have an AI application, because you cannot come to a conference these days without an AI app, right? That's all the hype these days. So let's run it, let's see if it runs, and then we will see what's actually inside the application. Before I begin, let me check my Java version. And I'm here on GraalVM version 23. So it's very easy to remember when there is a new release of GraalVM, because it's the exact same date and when there is a new Java release. So whenever new Java comes up, you also have a GraalVM release. And if I may suggest, whenever you need to download a new JDK, you can just download GraalVM, and this way you can get access to the latest Java features and the latest GraalVM features all in one place. How cool is that? So we have our JDK installation, seems good. Let's see what is actually our application about. So let's run it, Maven Spring Boot run.
So here we're running on regular JVM, right?
Yes, we are running on a regular JVM. So GraalVM is also a normal JVM. GraalVM doesn't mean that you need to go all in native image and ahead of time compilation. You can totally run application on the JVM, and GraalVM is just any other JDK, only it has a better, faster, top-tier optimizing compiler. And I want to say that this is running on a dedicated cloud instance, so it should be fairly isolated from my machine. My slides, all of that are not interfering with the execution of my program. So even on this fairly decent cloud machine, my application starts in 1.6 seconds. But let's see what it does. So I can go here and update my endpoint. And this is a little travel recommendation application that is using Spring AI, and namely OpenAI API, to provide us with travel recommendation. And also here you can check out how are my front-end development skills. I know it doesn't look like much, but trust me, it looks much better than it did in the first iteration of this application. So let's see how it works. Let's say we want to travel to the Netherlands, because that's where we are, and maybe the activity that we want to do is hiking, because, you know, why not, as one does in the Netherlands? And maybe we are feeling adventurous, so that is the kind of experience we are going after. Let's see. OK, Daniel, I don't know if I can pronounce it. It's for the Value region? What is that? Maybe you can tell us if that's any good recommendation for hiking in the Netherlands or not. But long story short, our application runs, and it has retrieved this recommendation from the OpenAI API. So let's go ahead and stop this. It runs on the JVM, right? But where is the fun in that? We are here to talk about GraalVM and native image. And for that, I have already prepared, because I don't want to intervene with the demo gods any more than I have to. I have my native Maven plugin. Let me just move this down. So this is in my POM.xml, and this plugin is, as you can tell, coming from the GraalVM team. And it helps build my application and test it, and also use dependencies from the native image side of things. So when you add native image at your start at spring.io, this dependency will take care of native compilation, and the Spring guys are nice enough to include this as a unified interface of configuring all things native image. So with that being said, let's compile our application. And just move this up. And since I have it there, I can just do maven p native compile. And now we will compile our app. Now, this is the simplest kind of path to a native image. If I was back at home and I was just not working on this application in my normal environment, I would have done a number of things to configure my application. But just for the sake of conference talk, I want to make like the smoothest possible transition ever. But if I were working on it at home, a few good things that I would have done are the following. So when I come back to my native Migrating plugin, this is the place where I would configure all things native image. And if I were working on this at home, I would have added a configuration block here so I can customize my build. And the number one thing that I would have added if I was still working on my application, so not deploying but still developing my app, is I would have added a -OB flag, and that means quick build mode. And this mode specifies that I'm not yet deploying my application, I'm still building it. So please don't optimize for production. I don't care about the speed yet. I just want to get my build quickly back to me so I can validate that my application still works. Now, before moving to production, remove that flag because it will not optimize for the speed as you probably would want in production, but it's very helpful as you're still building your app. So I would add it within my native Maven plugin, and also I would add additional things that I might want to. I could add more performance optimizations in this section, or I can specify, let's say, my application name, so I can then easier find it when I deploy my application. But just for quick, from-scratch build of native image application, this is all I need to do. I'm just adding my native Maven plugin, and it compiles. Now here, when I show this at conferences, people usually come to me and they complain, Alina, oh my God, this is taking so long. Why does it have to be so long? I don't have the attention span. Jesus Christ, do something about those build times. But check this out. So my application is fairly trivial. It contains maybe, 3, I think, Java classes, and granted, a little front end. But nevertheless, when native image compiles my application ahead of time, what it discovers is that my application has, 22K reachable types. So those are the types that actually are needed in my application to do what it's supposed to be doing. And then over 100,000 reachable methods out of almost 180K total. So even this fairly simple project, because I have my framework, my libraries, I have the entire JDK, it gives me good developer productivity, but it comes at a cost of complexity and the size of my project. That's why native image takes a while to build this application. But as I was chit-chatting, it was built in 1 minute, 25 seconds, which I would say not so bad. And if I had quick build mode, it would have been even 1 minute. But with that being said, let's run our application, and let's see if it still runs. So it starts, and if you remember previously, it started in 1.6 seconds. Now it's just 52 milliseconds. And if we go back to our endpoint, we can see that it's still available. And again, if we enter some data here, I don't know, maybe we want to go swimming this time, it will, again, send this call to the OpenAI API. And now we have one more recommendation of where we can travel in the Netherlands to the vast Frisian Islands, apparently. So this is an example of application that just works, TM. And isn't it nice when things just work, right? So very quickly about how native image is different from hotspot. So we have seen that application starts much faster than on the JVM, but then you can ask me, OK, fast startup sounds great for things like microservices, serverless, but what if I have a larger application and I don't deploy it that often and I don't care that much about startup times? In that case, I would argue, and even more importantly than startup, you could be caring about resources consumption, namely CPU and memory usage. And because we compile application ahead of time, native image gives you this trade-off where you can do all of that heavy lifting, compilation, loading classes, profiling, etc., at build time as opposed to runtime. And you can do all that work once, so you don't need to do it again at runtime. And this way, you can consume way less resources. On average, you can expect that, for example, memory-wise, which is probably the most expensive resource in the cloud, you would consume 3x, 5x less memory than the JVM. And this is happening ahead of time, so all the things that I need to know about your application needs to be known at build time. And the build time happens under closed rule assumption, meaning all those nice dynamic Java features, or as George Sloan calls them, the fun Java features, so reflection, serialization, proxies, resources, need to be configured at build time. And this means that some of the libraries, you will need to do extra work to make them compatible with GraalVM at native image, but we have you covered, and we will show you today exactly how. With that, let's talk about migration and how you can migrate your application. And with that, we will switch to Daniel's machine so we can go into more details. So we structured our session in a way where I showed you an application that works, and now we will break our application in all the right places. OK, all the drama, where is our machine? Yay, got it. OK, take it away.
Right, so if you want to migrate your current application that works, the first thing you need to do is, of course, use the GraalVM JDK. Otherwise, you can't do a GraalVM native image. Second, update to boot 3. If you're still on boot 2, I'm not going to ask you. It's fine. But it's out of open source support. So you should be migrating regardless of whether you do native or not. So that means using Java 17. And we have helpers. So in the Spring world, we have the App Advisor. Open Rewrite has a lot of recipes for helping you migrate. So that's a good excuse. If you want your work to be easier and faster, first trick is use the latest available GraalVM. Even if it's not allowed in production, while you're migrating your app, if you use the latest GraalVM, it will compile faster. So it will be easier to migrate. So maybe you do it on 23, and then you roll back to 21 to go in production. Use the latest Spring Boot versions. So the latest versions have better support for native. And then in development, as Alina said, use the -OB flag. When you do this, you can shave off like 30% of your build time sometimes. Like your app here would compile in less than a minute.
1 minute.
Yeah, about a minute, right? OK, so let's migrate an app. We started with a real application, but the problem with a real application is it may have several problems in the same point. So instead, what we did is we took this app and we split it up and we made small examples. So my app, I built it with Gradle. I'm sorry, Andres. And it's called the target is native compile. But Team Maven, Team Gradle.
Yes, Team Maven.
Oh, since this is compiling, I should remove my shoes like Venkat so that the demo works. So while it's compiling, the first thing you notice is, we go back to the GraalVM native image compiler that Alina has shown. But before that, there's a step where we have the Spring Boot banner. This happens in the process AOT task. So this is a task that happens before running native image. What is it for? Native image needs to know all the code that goes into your app. This is the closed world assumption. So basically, it runs into your main method and then looks at all the types you use and uses that plus metadata. Spring, it needs to know all the beans you use. But these beans were discovered at runtime before, right? You started your application, and then you did introspection to discover what you would want to load. That's not possible in native image. We can't change the code that's running. So we added an extra step that looks at all the beans in your app and then creates the bean graph for you. So in my examples here, in the build, we have some generated code in here. And so we have these bean factory registrations, which is just some code we can feed to the GraalVM native image compiler. And this one knows all the framework beans, but also my own beans that I use. So for example, controllers. I have an index controller. Well, this code, then the GraalVM native image compiler now finds it. So Spring helps you with this and generates everything you need. Also, as Alina said, dependencies, we work with library maintainers, and we contribute to the GraalVM open source reachability metadata repository so that all the dependencies that Spring Boot manage have the metadata to be able to work in native image. So this should be compiled now, I think. Yeah. See, 1 minute here on my machine. And so when I run this app, it's just like Alina's app. It works out of the box. So it could compile, and it will run, and I can just load this app. So it's a template, right? It has things in there, but it boots, and it has no problem. Now, the first problem that we get, and Alina gets a lot of flack at conferences, and people come and say, well, but reflection doesn't work on GraalVM.
Can we ask people, who here heard that GraalVM doesn't support reflection, at all? Still, many hands, and that's a bit unfortunate because this is not true. GraalVM does support reflection, including native image, but there are things to know. So some simpler cases, such as the ones that Daniel has here on the slides, will just work out of the box, no configuration, no JSON files, no anything, right? Right.
But for more advanced use cases, you need to do a little bit of work. So who knows when do you have reflection in your apps? When does that happen? Do you know?
Never.
Never.
That's a good one.
That's not true. And there's a hint on this slide. I'm going to help you. Here it is. Here it is. So every time you're having a string that creates some code or runs some code or some code that gets translated to a string, usually you get reflection. And this might be a problem. So let's see the types of string that could be a problem. First, this is a template. This is a time-leaf template, and it works. This works out of the box. So I have a template, and I can put the time at which I render the page, no problem. Let's look at the controller here. Is the font size OK in the back? Maybe you zoom a little bit.
Should be fine.
Let's do 200. So, typical time leaf, I get a variable, I put it in the model, and then I can render this, and it renders this, takes the string, renders the template, no problem. If your code is a little bit more evolved in your templates, that's when you start having problems. So let's go here, more templates. When I open this in native image, I get a 500 error. So here I have my first problem migrating my app. When you look at the stack trace in here, let's scroll up, scroll up, scroll up. So it tells you I had an error when I was rendering the templating.html template, and the method called title cannot be found on the type book. So the templating template is a very simple, very good name, right?
Yes.
It's a very simple template that takes a list of books, iterates over them, and then displays their title. These books, they're simple records, a record with a title in it. But what's happening under the hood is timeleaf reads this giant string, finds that this is code that should be executed, and then it says, well, I have an object book here, and I want to call the method called title on it. So it takes this string and converts that to calling some code. So here you have reflection happening. And so you need to do a little bit of work. So the Spring team, GraalVM allows you to control or give metadata to the compiler so that it knows about reflection that it cannot find, right? It's not going to run timeleaf. So you can write this JSON file, reflect config, and you say, oh, well, this state token converter, I want all public constructors. That's a bit complicated, and then you need to know the syntax, you need to get your strings right. So in the Spring team, what we did is we have a few things to help you do this, but programmatically. Here's my application class. In here, I can say a register reflection for binding, and I'm going to say the book class here in the, the templating template in here. Take this and put the metadata in the reflect config for me. So the next time I compile, the AOT compiler will look at this and generate the metadata for me. This, I put it on the application, but I can put it on any configuration class. So this happens to be a configuration class, but maybe you do your own configuration class. That's fine. So templates can be a problem. Another case where you have strings is, I'm a security guy. I work in the Spring security team, and we have these annotations with magic or Spring expression language strings in them, which is code. If you're using Spring Boot 3.3, then this is a problem. If you're using Spring Boot 3.4, which is going to come out this November, it works out of the box. So the type of strings you tend to get is, say, authorization controller. So there's this pre-authorized, and it has a string here. It says, well, find me the authorization service bean, and call is allowed on it. So if you're in an older version, you need to register this. Another way of registering it, still in my applications class, I can do import runtime hints, and I'm going to create a class. So examples, runtime hints.class. OK, create the class. Amazing. Yeah, sure. Implement the method. So it has one method, register hints. And with this API, I can say I want to register something for reflection. I can say, oh, register the type authorization service. And then what do I want to register? Maybe I want just the public methods. Or maybe I want to be able to access the public fields. Maybe I want to access. So I can control what goes into my binary. Or I can say, just give me everything. This will work. Values, right? This would work as well.
And this API in Spring is very nice, right? The runtime hints registrar API, because here we're configuring reflection, but it's more flexible than that. So if you remember those fun dynamic Java features, that is namely reflection, serialization, proxies, resources, JNI, this is a one centralized place where you can configure all of those things. Right now, Daniel is configuring programmatically config to access resources. And I really like this API because you can configure all those things just in one place. And I would argue this is a very nice programmatic way to configure things for native image. You don't need to write any JSON files manually. I think this is a fairly nice and developer-friendly way to go.
Right. And so resources, JNI, proxies. Anybody use JNI in here? Oh, I'm sorry.
You like shy hands.
All right. So that's magic strings. There's another place where code interacts with strings, and this is when you serialize or deserialize to a text format. So in more recent, more modern applications, when you're producing JSON, if you're doing banking and you're doing XML, I'm sorry, but this is also text. So when you get JSON data and transform it to an instance of a class, then you have reflection happening. When you take a class and write JSON or write XML, reflection happening. So let's see that. Maybe, you know what, I'm going to put some lines, new lines here so we can see it better. And refresh. There we go. So in here, this thing tells me I cannot construct an instance of remote API data. I can't deserialize. But also it tells me this appears to be a native image, in which case you need to configure reflection for the type remote
But what
API.
a nice error message. Can we appreciate this? Very specific, not just one big scary stack trace.
Exactly. So in my JSON controller in here, what's happening is I am calling a remote service in here, and I say, get me this JSON and put the data in this remote API data. So Jackson, which deserializes the message, needs to say, oh, OK, then I have a JSON object, and it has a title field. So I need to put it in something in remote API data that looks like title. So it needs to do reflection. So again, we could register it at the application level in here. There's also another way. So this is centralized configuration. If you want, you can also annotate the types you want to have reflection on themselves. So in that case, you enable reflective scan. And then in your types, in your records, in your classes, in here you can register reflection for binding, or if you have very specific needs, you can do reflective. But
so this can be helpful, for example, if I want to make this type available to other places in my application, right? So maybe I know that many places call it, so I can just annotate it here, and it will make it visible everywhere.
So in here, we were reading text and making files. If we were to do, say, writing Java instances to text, so doing a post, and then in here we have a body. This takes my Java instance and says, oh, it has a field title, so I'm going to make a JSON property title. So in here, this would be a problem. Or if you call object mapper directly, when you call read or write, this is a problem. So again, right, we have the example of writing JSON. This fails in the same way. Let's see, in here it says blah, blah, blah. This is a native image. You want book to serialize to be registered for reflection. So again, in here, I would need to maybe annotate this type or something. Ignore it so we can see a failure later on. Right. OK. And then there's one last way of producing JSON, which is calling a REST API endpoint. So in here, my API, JSON/JSON/API, returns a list of book API response, which gets turned into a string that is sent to my browser. This works. I don't have to do anything for this. So in here, if I open this, I can go to this, raw data, pretty print. This works. This is because this is a Spring managed bean. We know it's a controller. We know you're going to be producing JSON by just looking, oh, this is annotated, it's public, and I look at the signature. So anything, the return type, Spring is going to register it for reflection for you, and anything in the signature in here, we would register as well. So you don't need to do it manually. OK, strings covered. So remember, if you're doing stuff that does code to string, string to code, this is where you have reflection problems. So in templates, Spring expression language, serializing, deserializing to JSON, XML, or whatever text format you use. Third parties, libraries that do this may not be compatible as well, right? Or if they serialize your types, then you need to register your types. In Spring, we have APIs to help you do this without having to write the JSON manually. So import runtime hints, register reflection from binding, reflective scan, depending on what you want to do. And most of the time, if it's in the signature of the method of your bean, so controller service, repository, we know you're going to use that in reflection, and so we register it for you. And in the recent versions of Spring Boot, pre-authorized, post-authorized, that's already covered. So what we're doing here is we're discovering the problems as we go with our legacy app, or the work that we need to do. And so we would need to recompile, run the app, click again, verify that it works, and then find the new places where we have problems. So it would be nice to be able to automate this. So we can do one thing where we compile our tests and run our tests in native mode. So in Gradle, There we go. Oops. Allow, yeah, sure, whatever.
So for testing, what you also want to do is to use our plugins. So Maven or Gradle plugins coming from the native build tools project, and there is included support for testing, such as from JUnity testing. And this is something we will do now, where we will run our tests in the native image mode, where the tests themselves are compiled to a native executable, so you can verify that your application runs just fine in the native image mode.
So there are limitations to this. The biggest limitation is mockbean, spybean. Now in Spring Framework 6.2, it's called Mockitobean because it moves out of boot into framework. Well, this is, of course, what was happening when I created the presentation. But my coworkers like to crash my presentations, and now mockbean or Mockitobean is supported in Reflection. There are limitations to what you can do with Mockito, but Spring Framework supports this. So when Alina saw that on Twitter, she was like, Daniel, change your presentation. So here it is.
This happened the night before our presentation at Davox Belgium. So.
Right, so I had to cut short my speaker dinner to update the presentation.
Yay.
So in case you're using older versions of Spring Framework, then something like this test that uses a bean fails in AOT mode and in native mode. So it runs on the JVM, no problems. If I run this, it needs to compile it, but no problem. If I run it in native, it would fail. So what I can do is annotate my test and say, don't run this in native mode. So if I have tests that use things not supported on native, I can turn them off. If I want to create some special tests just for native so that they touch everything in my application, I make sure I'm not breaking anything very deep, it's an integration test of a thing that I deployed, I can also do the opposite. I can say enabled in native image. This restricts this test to running in native image. So if I run the test again, then in the JVM, it's turned off, right? So my results should be in, right? They failed because we left a thing that we knew was broken. So it found 4 containers, 4 test classes, if you will. It skipped one. The one said disabled in AOT mode. It found 7 tests, skipped 1, and then 4 tests were successful, 2 failed. And when you go and look at the details of the test that failed, it say, well, this JSON controller booked to serialize was a problem, and this is a native image, and you need to register it. So now you're shortening your feedback loop, right? You run your native tests that touch everything. You see the problems, and you fix them as you go instead of going and clicking. So takeaways for Spring, native test with Gradle or Maven. Avoid mockbean, spikebean, Mockitobean if you can. And what you want to be doing is touching your entire application. So write integration tests. Maybe use test containers. Test containers is supported in native image so that you know you touch all your classes. But the goal is not to check all the business logic, right?
Right. So when it comes to development practices, in general, our recommendation is even when you are doing native image, continue developing your application on the JVM, building and testing on the JVM. This way, you can validate all your assumptions and validate that your application still works. And when it comes to compiling to native image, to validate that it works specifically in the native image mode, those are our recommendations. So one is you can do it in your CI/CD because you want to make sure that everything still works in your CI/CD. You can also do it maybe once a day just to be sure. But overall, you don't need to compile to native as you're introducing minor changes to your business logic because things will just work. And if you're staying in this world where you're on a version of a framework that is compatible with native image, such as Spring 3.0 and higher, and compatible libraries, which are at this point most of mainstream Java libraries, things will just work for you. You don't need to recompile all the time. Times when you want to recompile to native is, for example, when you're introducing a new dependency and you don't know whether or not it's compatible with native image, so you want to recompile to native, make sure that that dependency works. Or if you're attaching things that you know are sensitive to native image. So if you're attaching reflection, serialization, resources, etc., you might want to recompile one extra time to validate your assumptions. But overall, our recommendation is build your application on the JVM, test on the JVM, and then leverage the framework support to make sure that things just work for you. But overall, stay in that JVM world. You don't need to recompile to native every 5 minutes or so.
And so if you like living on the edge, then you can do Mockito. That's fine. So takeaway. Don't test native all the time. We're not telling you not to test. Don't go see your boss and tell them, like Alina and Daniel told us, it's OK not to run tests. Test responsibly, do your tests, do them on the JVM, and it will be fast. And then native test is a tool to help you verify you haven't broken anything. OK, last dynamic bit that Spring does is dependency injection, right? Finding these beans. So I have an example in here, a beans controller. And this controller uses two things, a language service and a mood service. These are constructed depending on properties and profiles. So this mood service has a happy service and a sad service here, right? So if app.mood is sad, then you get the sad service. If app.mood is happy, or if it's missing, you get the happy service. Same, we have a language service. And so if the profile is French, you get the French profile with the haricots français. And if the profile is not French, by default, you get the English profile, which gives you one English bean. So to change profiles or values, you can do it in many ways in Spring. So environment variables, or the command line, or say a config file. So let's do the command line. So I have examples, build, native, compile, examples. And so in here, I can do spring.profiles.active equals French, and we're at JFull, so let's put JFull. And then app.mood is sad, right? So this runs, and when I go inspect at runtime, what's happening in my conditional thing? So the profile is taken into account, French and JFull. The app.mood is taken into account. But I had the French profile, and I get the English beans. This is absolutely unacceptable for the French profile. Same, we had the app.mood to sad, but we get the happy service. Why is this happening? It's because if you remember, your bean graph, all the beans that you're going to be using, is decided at build time, at the process ahead of time, process AOT phase. So there is no reference to a French language service in my, the bean registration, this one. So in here, we have a happy service and an English language service. So if I want the French service, I need to compile with a French profile. This is important for two things. One, you need to be aware of it and put the right properties. Two, Spring Boot does a lot of loading classes on your behalf, depending on your properties. So for example, if we're doing what Spring Security provides, so in here, Spring Security, OAuth2, client provider, issue URI, and then this is, whatever, Okta or something. So in here, if you have this, then Spring Security will create some beans for you. These need to be present at build time. You don't need to put the real values at build times, though, because when we create your bean graph, we don't spin up the beans, right? We don't actually connect to your database. We don't connect to your OpenID provider. We just decide, oh, the condition says this one should be present. OK, so that means you need to fix you do the close world at build time. This may be a problem. Say you have a very different staging and production environment. Maybe in staging you're using MySQL, and in production you're using Oracle, and so you have slightly different dialects, and you need to do different beans. So you can do two things. You can generate compile a staging binary and a production binary. But maybe you want...
doesn't sound good.
Right. Maybe you want to test what goes in production. Maybe you want to test it in staging as well, instead of having two things. So there's a way around this limitation in, say, the language service here. Instead of having components that are loaded by profile in here, I'm just going to make those classes. And in any configuration class, let's put it here, I can provide a bean of type language service. This is the interface behind these two things. And when I construct this bean, at runtime, I can inspect the environment. And the environment has environment get active profiles. So this is in an array. And so with this, I can say, oh, does it contain French? And if it contains French, then I return the new French language service. Otherwise, return a new English language service. And so the GraalVM compiler will see, or like the AOT compiler from Spring will produce code that says, I need this method. And so the GraalVM compiler says, OK, I'm getting inside that method, and I see that you need both the French and English language service. And so you get your dynamic behavior back.
So basically, an image can do anything for you as long as you instructed at build time what needs to be happening, right? Because the runtime hasn't happened yet. There are tricks around it. But the rule of thumb is whatever you want image to do, you need to kind of acknowledge and make it known at build time. And then it can do pretty much whatever for you.
So in Spring, beware of annotations that decide which code runs dynamically. So add profile, add conditional, on blah, blah, blah. Other annotations, add value. We've seen that app.mood is picked up. Profile is picked up. So anything that's not related to class, fine. Anything that's not conditional, so add controller, that is always present, is not a problem. It's handled for you. OK, and then the last big hurdle that you might get into is unsupported libraries. So the GraalVM, if you search online, GraalVM libraries. Right, this one. So there's a list of libraries that do work on GraalVM. So in here, a huge list of everything. So maybe, I don't know, you want to do...
So bear in mind that there might be more. Those are just known to be continuously working and integrating and testing with GraalVM. This is a community-maintained list. That doesn't mean that if your library is not here, it doesn't work. This is just something that has been reported to us to be known that it works. And this is a list of what, maybe like 200-something libraries that are known to be continuously testing with GraalVM.
So these work. And so if they have 2 stars, they tend to be maintained by the projects themselves. If they have 1 star, it means the community can contribute all the metadata required to make it work on GraalVM. So you can go and find the repository, which is here, and go make a contribution if you have a library that's
such as Daniel did to improve our test container support in native image.
Exactly, right. But sometimes the library you're looking for is not on that list. So we're at a technical conference, so I know that some of you in here work in a bank. I know it. I know deep in my heart. And after the talk, you're going to come and talk to me and ask me how to generate Excel spreadsheets. And Excel spreadsheets is done through Apache POI, which is the reference library for generating.
Also Daniel's favorite library out there.
You make me do this. You make me do this, you people. So native, I have a books application in here. So it just showcases my books, right? So the collection of books, right? It has, authors and so on, and it has an export feature which uses Excel. So if I click on it, 500, typical error that we see, when we have some work to do. And so up there it tells you, well, in here, class not found. Org Apache XML beans implementation store locale. So this is not my code. This is coming from this Apache POI library. So,
and the reason why we cannot do, for example, annotations here, such as we showed before, that there is a nice programmatic way to generate config for native image, is because it's a third-party library. There's a lot going on, and probably do not know it as well as the maintainers do. So if you wanted to go and annotate every single thing in there, it might be problematic. But luckily, there is a semi-automatic way to produce config for native image.
Right, so, because I've tried. If you go in there and you annotate and you say, oh, this type, some types are private, so you need to do reflection to get the type. And then you fix one type, and then you run the program again, and then you get another problem, and another problem, and another problem, and you have a very sad and boring week. So instead, the fine folks at Oracle Labs have given us a way to do this automatically.
Right, so the way this works is that native image comes with a tracing agent that you can run your application on the JVM with this tracing agent attached to it. And the next important step is that you apply a relevant workload to it, because you need to show us what exactly will be happening in your application. Such as, for example, if our application is supposed to start and then expose an endpoint, and there is some logic in that endpoint, you need to apply that workload to let us know what it's supposed to be doing. And then what the agent will do, it will produce those magical JSON config files for you for all those dynamic features such as reflection. Now, it will produce config for everything that it sees in the app, not only for the things that are breaking, but it's a very good automatic way to produce configuration, and many of those libraries that are made to be working through our reachability repo have been configured using this tracing agent that just observes your application behavior. But the key element there, apply relevant workload so we can see what your application is supposed to be doing.
Right, so here I'm running my app in the JDK, in the JVM, not in native, with the agent. So when I go now and I refresh the page, well, this time it works, right? The export works because it's on the JVM, so I don't have this problem. When I stop this application, now in my app, in my books here, in the build output, in native agent output, a boot run is the thing that I ran. I have this reachability metadata file, and so in here, what was it, implementation.locale? No, it was store.locale. Here we go. So it found that type for me. And it found a bunch of other XML or Apache XML beans, right? So if you have to do this manually, you're going to have a sad week.
I mean, maybe you don't need all of it, but it's all that it sees in the app, so it produces config for all of it just in case, basically.
And so you're taking this file here, and you want to feed it to the native image compiler. How do you do this? In your class path, in the class path of your application, you create a directory meta-inf/native image, and then a name. So in here, we're doing Excel, so let's call it Excel. And then you copy this file in here.
Or you could pass a property to just instruct it to put it in a place where native image can pick it up from.
Right, and so we're not going to recompile and show that it works, but now we have all the types to make this work at all. So the takeaway from this is tracing agent will find resources, proxies, reflection for you. You can run it in your app with Maven or Gradle. If you have a compiled jar and you don't have Gradle or you're not using the native build tools, you can just run the plain Java jar by passing the agent in the command line. You do need to check compatibilities, though. Sometimes there are things that are not supported yet. So for example, if you're doing AWT, Advanced Window Toolkit on Java, it doesn't work on macOS. So the GraalVM team has done work to make it work on both Linux and Windows, but it doesn't work on macOS. So if you compile a Mac binary with AWT, that's not going to work. Some libraries might be fully incompatible. So when we first started doing that talk, Apache POI 5 relied on log4j 2, and this used features that were not supported by GraalVM. Now, the log4j team has started implemented support and changing their code so that it compiles. So the further you go, the more libraries will be supported and the less problems you will have.
And I must say, this is already getting a bit into the woods. We kind of hope that you will never have to get here where you even need to use the tracing agent. So if you're using more kind of mainstream Java libraries, most of them are compatible out of the box. Either they ship config or that config is present in our centralized repo. But if you are using some older libraries, some that hasn't picked up native image support yet, the tracing agent can help you provide those configuration files for native image.
Exactly. So I said AWT doesn't work on macOS. There is one limitation that is not inherent to Spring, that is with GraalVM or a native image, is that you need to compile for a specific target, because it's a binary. It's not Java run everywhere anymore, right?
Yes, so the way native image works is when you have your application compiled, in the end, it's a native executable, and it's specific to the platform and architecture on which you are building your application. We cannot do cross-platform compilation out of the box, at least, because we need some JDK classes that are specific to each platform. But there are many ways around it. So one thing is you can do things like CI/CD. For example, for my own project, I'm using GitHub Actions. I'm a big fan of GitHub Actions that you can just configure building for whatever platforms you need, either for yourself or for your users. It will just work and produce for the platforms that you need. Or obviously, you can do containers, and there you can use, for example, the things called build packs that, for example, the Spring team endorses. And this way, you can also have build the application for all the platforms where you might need to use it.
So in the Spring team, in our commercial products that we sell to our customers, we have the application advisor. This has a CLI, and we compile this CLI on GitHub Actions for Linux, macOS, Windows, 30-bit, 64-bit, and so on. So it's a thing you can do, right? OK, how much time? 5 minutes?
5 minutes.
All right.
Performance, perfect timing.
Exactly. So why are we doing all of this, right? We're not doing this because we love having extra work to do, right? We're doing this because we want to gain something. And we want to gain mostly, like the number one thing that people want is performance.
OK, let's see if I get my screen. Perfect. OK, so now we will do a performance demo. And coming from the Java space, we all love and care about our peak throughput, right? So the JVM is a real beast when it comes to peak throughput. So where does native image stand there comparing to peak throughput with the JVM? And here is a place where my people tell me that AOT compiled code will never be as fast as the JVM. So let's see if that is actually true. For that, we will benchmark yet another application, and we will send 1 million requests to our application. The application itself is a dictionary app. I will not show it because I want to save time, because we will need to do 3 benchmarking runs. But if you want to learn some more Swiss German or learn any Swiss German at all, catch me during the break, and I will show you the actual output of this dictionary app. But with that, let's benchmark our application, and we will benchmark it in a way that we will send 1 million requests to our application, and then we will be able to compare performance of the JVM version versus the native application. So let's benchmark the JVM version. Let's see, and this runs with C2. C2 is the default compiler in OpenJDK, so the default compiler that you get when you think about Java. Okay.
So in here, right, the green is the number of requests 1 second, 2 seconds, 3 seconds ago, and the blue line is your million requests that are going on. Forget about the yellow line. It's response times, which is the benchmark. It's not optimized for this. So maybe run it one more time.
So we will look into that. One more thing that I want to add is that we are waiting in the beginning 5 seconds. So we are giving the JVM a chance to start. We are not rushing with our request just yet. So it has a chance to start. And also, as I mentioned before, it runs on a fairly beefy machine. So it should be able to show whatever it can do for our application. Let's see. So waiting 5 seconds, and now we will send the actual load. And let me adjust the view.
Right, so the first bar is it made 5,000 requests in the first seconds, 23,000
So you can see the warm-up,
requests.
right, where it gets faster over time.
This is because it's a big machine. If you have a small cloud pod, then your JVM may take up to a minute to warm up, or 3 minutes, or 10 minutes.
So we can look at latency times, but I like looking at peak throughput. For me, that's the most kind of telling number. Here for our JVM, even after 2 runs, it's at 79K requests per second. So let's run a native version of this application, bench native. So this is 79K.
So it's much faster. So if you're doing
serverless, but it's
serverless,
waiting because we want to wait like we are waiting on the JVM. Oh, OK, let me adjust this.
But then here, we don't warm up.
Yes, we are just waiting like we were waiting with the JVM to have a comparable setup. So who thinks this will be faster than the JVM? A lot of skeptical people. You don't give me enough credit. OK, it was 79K. Now with the native image application, we get 53K, which is, maybe not as impressive, maybe not the result we would like to get. Albeit JVM is great at peak throughput, but maybe we still want to do something about it. For that, I will do one more final run. I have an application compiled with additional optimizations in place, and I will tell you what they are in a second. So this is running my native optimized, waiting again 5 seconds like it had to wait with the JVM. And let me just zoom this out. OK, so this is running with profile-guided optimizations, where we have built our application as an instrumented version, collected profiles, and then fed those profiles back into native image, so it can have the runtime awareness similar to what the JVM has. So it has PGO, it has the G1GC, and it has MARC native, which says, please make the most out of this machine where you are building at. Don't optimize for compatibility, optimize for the best peak throughput. Now, if you remember, our JVM was at 79K requests per second, and now our native image is at 80K.8, which is perfect, just a little bit over, but I love it.
It's comparable. So the takeoff is like, if you do native, and you just make it work in native, you'll still get 60% of the peak JVM performance. If you need peak performance, because you have millions of users, then you can do what the JVM does for you. You just do it in a different way, and you feed that profile at compile time.
Now, here I need to say that this is by no means a scientific benchmarking. Scientific benchmarking would have taken at least half an hour in proper warm-up, and proper measurements, etc. But hopefully, it gets across the point that if you apply all those optimizations, you can get much more throughput from a native image applications that you would get out of the box. So if you want to have good peak throughput, this is also something that native image can give to you, in addition to fast startup, low memory usage, and even better security. With that, we would like to summarize. So hopefully, we've shown you today how with native image you can get fast startup, lower resources usage, namely CPU and memory usage, and also you can get compact packaging, even smaller with the latest GraalVM release, where we are always working to make sure you can have faster builds and smaller native executables. What about the recommendations?
So again, use the latest. Even if you don't deploy with Graal 23, use Graal 23. Migrate to more recent boot versions. Anyway, they're going out of support as you go, so you should be migrating. And do your development and your test on the JVM. If it's a new app, you usually don't have a problem. If it's an app that you migrate, you will be compiling a little bit more to native while you are migrating. And then compile, when you deploy, compile close to where, or on the same architecture that you're going to deploy to. So compile close to production or in a dedicated CI space. So the demo worked. I can put my shoes back on.
Yes, you should. With that, this is all that we had for you today. If you have any questions, we will be here, or you can reach out to us on social media. And please come talk to us, and please rate this session. Thank you so much for coming.
Thank you.